sklearn, linear model, orthogonal MP. Description: the orthogonal matching pursuit OMP is a greedy algorithm for sparse signal recovery. Used in compressed sensing, it attempts to find the sparsest solution to a linear system of equations. Inputs: X a 2D array of shape n samples. N features representing the design matrix. Each row corresponds to a sample, and each column corresponds to a feature. Y a 1D array of shape n samples, representing the target values. Outputs: Core a 1D array of shape n features, representing the estimated coefficients of the sparse solution. Nit is an integer indicating the number of iterations the algorithm ran before converging. Steps: initialize the coefficient vector to all zeros. Iterate until the stopping criteria are met. Calculate the residuals between the predicted and actual target values. Find the feature that is most correlated with the residuals. Add the corresponding feature to the support set. Update the coefficient vector using least squares regression on the selected features. Metrics: mean squared error MSE measures the average squared difference between the predicted and actual. Target values: R squared measures the proportion of the variance in the target values that is explained by P. Model: visualization plots. Scatter plot of the predicted vs. actual target values. Bar plot of the estimated coefficients, highlighting the non-zero coefficients. Fine-tune parameters. N non-zero coefs, the maximum number of non-zero coefficients to allow in the solution. Toll the tolerance for the stopping criteria. Precompute whether to precompute the gram matrix of the design matrix. Uncertainty methods. Bootstrapping: repeatedly sample with replacement from the data and fit the model to each sample. To estimate the uncertainty in the coefficients. Challenges and fixes. Challenge 1: the OMP algorithm can get stuck in a local minimum, leading to a suboptimal solution. Sample use case that resulted in challenge 1: a highly correlated design matrix with a sparse signal. Fixes to challenge 1: increase the number of iterations. Use a different initialization for the coefficient vector. Challenge 2: the OMP algorithm can be sensitive to noise in the data. Sample use case that resulted in challenge 2: noisy measurements of the signal. Fixes to challenge 2: use a robust regression method to handle outliers. Use a regularization technique to penalize large coefficients.